Thank you for that.
No.
Okay, so let's do number 8 first. Consider this curve is find the values of A and B. So, oh, and this is, so there's 3 questions.
Yeah, there's
8,
so
9, and
normal
this.
line thing. Yeah.
Okay. So we'll do this one first. Okay, so I think I'm going to show you the graph of that first.
Okay.
Any idea what we're talking about here? No?
No.
It's okay. Well, I'm just trying to figure out my level of explanation. X cubed minus 3x squared minus 9x plus 5. Okay. This will give you a conceptual understanding of what's actually happening here. Okay. All right, so here's the graph of that function. And I want to do one more thing here. Okay. All right. So basically the stationary points is where the slope of the tangent line to the curve is equal to 0.
Okay.
Okay. So which means the slope of the curve at that particular point is also 0.
Okay.
Okay. So that means we have a horizontal tangent line to the curve, right? So from this curve, we can see it's here.
Yeah.
And that's going to be at x equals -1.
Mm-hmm.
And then here, oops, down here, right?
Yeah.
Okay. So how do we use calculus to do that? Well, we use the derivative. And remember, I told you that the derivative gives you the slope, or the gradient, I should say gradient, sorry, because IB says gradient, the gradient of the tangent line to the curve.
Yeah.
Okay. So to the left of this stationary point, my tangent lines all look like this in the sense that their gradient is positive.
Yeah.
Right? So like if I were to move this up, right? Positive, 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 and I'm not adjusting the tangent line, right?
Yeah.
Until it tilts, 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 and then it really starts to tilt, right? Until the tangent is 0.
Yeah.
Right? The key thing is the derivative for all of these x values, when I plug it in, is going to be positive. In other words, the gradient is going to be positive, 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 positive.
Yeah.
And then do you see here how it switched to negative, 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 until it's 0 again, positive, 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 positive.
Yeah.
Okay. Now, since the derivative gives us the gradient, we don't need the graph.
Okay.
Okay. So if we set the derivative equal to 0, we're going to find x equals -1 and x equals 3.
Yeah.
Again, the derivative gives every point on the curve, the slope of every single point on the curve. To find a particular point, we plug in the x value.
Okay.
Okay. So f prime of x is going to equal what?
3x squared minus 6x minus 9.
Okay.
And that's it.
Derivative gives us all of the gradients everywhere. So the first thing we want to know is where the heck does that, where is that equal to 0? So I'm going to set the derivative equal to 0. And how would you solve that?
I would factor it probably.
Would you factor out a 3 first?
I'm really bad at that, so I don't know.
I would factor out a 3 first. Then you don't have a coefficient to worry about. Okay, so your solutions are just going to come from here. You want to take a stab at it?
X. Is that 2 and 1? So -2 and -1?
Well, you're thinking just a little off. I need factors of 3. Okay, I need numbers that multiply and give me 3.
3 and -1, or
well, let's throw the 3 and 1 in there, right?
Yeah.
How well do you know FOIL?
I can do FOIL pretty well.
Okay, so we're kind of reverse foiling, right? Right. So that's why, you know, the FOIL, L for last, the product of the last terms gives me this constant, right?
Yeah.
Okay.
So -3 and +1?
Yes. Now, how do you know the 3 is negative and the 1 is positive and not the other way around?
Because if you did the other way around, then 3 minus 1 would be +2 instead of -2.
So you know how to factor. Okay. Oh, looky, looky, looky. X equals 3, X equals -1. Just like
Do you not need the 3 multiplied in the front anymore?
No, because what's really happening there is, instead of factoring, we could think of dividing every single thing by 3. Right?
Okay.
And 0 divided by 3.
Oh, yeah.
Or at this point, we could divide both sides by 3. And we're just left with this.
Okay.
So no, it doesn't matter. Now, we could have gotten it. We didn't have to factor out that 3. It just makes the factoring a little bit more confusing. That's all.
Yeah.
Okay. So these are stationary points. Some folks will call them critical points, right?
Yeah.
And do you see how this guy right here, let me get rid of the tangent line now. Okay, do you see how this guy here is sort of a maximum? in
Yeah.
that it's a local maximum, because in this local area, it's the highest point.
Yeah.
It's not the absolute maximum because this graph goes forever and ever and ever and ever.
Yeah.
Or your teacher might call it global maximum. Not sure. Okay. Well, how the heck do we know that? Well, we do what's called a sign diagram, SIGN, as in positive or negative. Okay. And what we do is we say, okay, F prime, right?
Yeah.
And we put where the derivative is equal to 0, which is at -1 and 3, right? Okay. And again, this is a sign diagram for the derivative. And what that means is we're saying we're trying to figure out where, which intervals is the derivative positive and which intervals is it negative.
Okay.
Okay. Now looking at it to the left of -1, we know the slope is positive, 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 right?
Right.
All the way up forever and ever and ever. Okay. Well, since the derivative gives us the slope, the gradient, that means if I plug in any number to the left of -1, it will turn out positive,
Yeah.
right? Now, we probably don't know that without the graph, but we don't need the graph. So you choose any number you would like to the left of -2 and plug it into the derivative. Okay. Now, you could plug it in here, right? But all of these are equal to the derivative.
Yeah.
And since you would have to be careful, because if I want to use this, it's just easier. But you need to make sure that you factor out a positive number if you're going to use the factored form,
Okay.
because a positive isn't going to affect anything as far as the sign. If it was negative, it's totally going to affect the sign. So you got to keep an eye on that. If that makes you nervous, just plug it in the original derivative.
Okay.
Okay. But if you're able to get here, you can say, okay, I select -2. Well, that would be a -5 times a -1,
Mm-hmm.
which is a positive. Negative times a negative is a positive. So we just put a plus there.
And this is to do what? To find what?
Well, we're going to classify. We found the stationary points. Now I'm going to show you how to classify them.
Oh, okay, I see.
And what the classification is, this is a local maximum.
Okay.
So we have to determine that from the derivative in the sign diagram.
Okay.
Okay. One other point here, we don't care about the value here at all. We don't care that the value is, I think it would have been a +5.
Yeah.
All I care is that it was positive, right?
Yeah.
So you don't want to clutter your mind unnecessarily. Like, okay, I plug in a -2, and maybe in your head, okay, if I plug in into -2, that's a negative. Plug in a -2, that's a negative. Negative times a negative, positive, and you're done with it.
Yeah.
Okay. We love the interval that has 0 on it, right? Because we're going to choose that. Negative, and we get a negative times a positive. Well, that's a negative, yes.
Yeah.
I'm going to choose 4, positive, positive, positive. Okay.
Okay.
So this tells us a lot of things here, but we'll talk about the points, the stationary points, right? First, this tells us that the graph to the left of -1 is increasing, then it equals 0, and then it decreases, which means we have to have a maximum or a local maximum there.
Yeah.
Okay. So stationary points, we would say at x equals -1, or I guess since they say stationary points, the point x equal, you don't have to write all this out for IB. I'd say x equals -1, local max. Local max. And I know it's local because it's a cubic.
Yeah.
Okay. And so same idea here. So then it starts decreasing, 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 decreasing equals 0, and then it's positive, so it's decreasing. So at x equals 3, I have a local min. Why do I keep putting an m there? Local min. You could also say local max at x equals -1, local min at x equals 3.
Okay.
So you have found and classified the stationary points.
Okay. Perfect. Thank you.
Does that make sense?
Yeah, it does.
The other thing that this tells you, and I already said it, but just to drive it home, like if we don't have this drawing, bonk, we know that to the left of -1, the graph is going up. Between -1 and 3, the graph is going down. And to the right of
Yeah.
+3, it's going up.
Yeah.
And we have a max and a min, so we can get a pretty good sketch, right?
Yeah.
Of it right there. And what we could also do if we had to, and they didn't say coordinates, they just said stationary points. You need to check with your teacher on this, but you could find the y coordinate, couldn't you?
Yeah.
How could you do that?
By substituting the x
Into where? Yes, into where?
into the original function.
Yes. Yes, yes, yes,
Okay.
yes. Good. Excellent. Okay, so now we'll do number 8. Okay.
Yeah.
That was the hardest. The station, that was a lot.
Yeah. Okay.
Consider the curve y equals x squared, blah, 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 blah. The tangent to this curve at the point where x equals 1 is 2x plus y equals 6. Find the values of a and b. No problem. Okay. Do you know, you said that you knew how to write the equation of a tangent line, right?
Yeah, because we did that last time where we looked at tangent lines, but this is kind of the other way around. So I was a bit confused.
Right. Okay. But you know how to do that.
Yeah.
So it's really the same idea. Okay.
Okay.
So from this, we know that, let's see, 2x plus y equals 6. So then y equals -2x plus 6. Is that okay? That's the tangent line.
Yeah.
And so that tells us that the slope is equal to -2.
Yeah.
Good?
Yeah.
So then that means that y prime of 1 equals -2.
Why is it of 1? Oh, because x equals 1.
Yep. Good.
Yeah.
Okay. So that means if I find y prime, what's the derivative of y?
Hold on, -2.
No, of just the general
Oh,
function. Sorry.
2x. 2x plus a.
Excellent. Right. And so, I'm sorry. And doesn't this give us an ordered pair for the derivative? This y prime of 1 equals -2?
What's an ordered pair?
xy coordinate.
Okay.
When x equals 1, y equals -2.
Yeah. Yeah.
Okay. Which we can then plug in here. -2 is equal to 2 times 1 plus a.
Okay.
So -4 equals a.
Yeah.
Woohoo!
Okay.
I apologize for that. All right. So now we know that y equals x squared minus 2x plus b. Am I right?
Mhm.
Okay, so we also know, since it's tangent to the curve at the point where x equals 1, that 1 is on the curve,
Yeah.
right? It's also on the tangent line.
Yeah.
So if it's on the tangent line, so I'll say point of tangency. Do you know what that means?
Where the tangent line hits the line.
Yep.
Okay.
Is also on curve, right? It has to be.
Yeah.
Yay. So that means it has to satisfy y equal, or 2x plus y equals 6. I'll just take the original.
Mhm.
And the point in question is x equals 1, right?
Yeah.
So then 2 times 1 plus y equals 6. So then y equals 4.
Yeah.
So 1, 4 is on the curve. Do you agree?
Yeah.
Which is wonderful news, because the curve, I should have put this down here. So we have y equals x squared minus 2x plus b, right?
Yeah.
And I have a point on the curve, so I can substitute it in here for
Mhm.
equals 1 minus 2 plus b. Is that okay, skipping those steps?
Yeah.
So then minus 1, add 1, so b equals 5.
Makes sense.
Woohoo!
Cool.
Okay.
Yeah.
All right. Okay, so now we just have number 9. Did that move when I did that? Did you just see it move?
No.
Okay, it's just on my screen. I'm just getting the other stuff out of the way. Okay. Find the tangent to that horrible thing. Okay, this isn't the normal.
No, the normal is, that's a separate question.
Okay, you didn't give me that one, right?
No, I was just, the general concept of finding a normal line
Okay.
confused me.
Okay. Okay, so we have to find the equation of the tangent line, don't we?
Yeah.
Okay, so that means we need a point on the tangent line, and we need a point and the slope, right?
Yeah.
So let's just get the point out of the way. The point is at 1y, right?
Mhm.
Which means if I plug into the original equation, are you okay with that?
Yeah.
I get 1e.
Why is that? Because it's just 1 times e.
Yeah, so y equals x squared e to the x. So y equals 1 squared e to the
Oh,
1,
okay.
right?
Yeah.
Equals
Yeah.
e. Okay,
Yeah.
so point is 1e. Stop it. 1e, right?
Yeah.
Okay, so the point, and so the gradient, I apologize for always saying slope. I find the
It's okay.
derivative, right?
You what? sorry.
You find the derivative to find the gradient.
Yeah.
Okay.
So 2x times xe.
For this is we usually we hate e to the x because we hate e because we don't understand it, but we love it in
Yeah.
calculus because the derivative of e to the x is e to the x.
Oh, okay. So just e to the x.
Yes. However, this you have to use the product rule because we have the product of two functions.
Oh, right. Yeah.
So so you're right, but you were wrong being right.
Okay.
Because you actually thought you had to take the derivative, right?
Yeah.
Okay, so derivative of the first times the second plus
just x squared.
Now you take the derivative of
times-
e to the x.
Times the same thing.
Yeah,
Okay.
and we need the slope at x equals 1, right?
Yeah.
So now we find
So-
what? Go ahead.
2 times e plus 1. No, was it 1? Yeah.
Mhm.
1 times e again. So just e. So 3e.
Yay. So tangent line would be what? Or the equation of the tangent line. We have our
The
point
slope.
and we have our slope.
So e equals 3e plus b. No, 3e. Yeah, 3e plus b.
Well, we're writing the equation of tangent line.
Yeah.
So we're going to use point slope form. Are you familiar
Okay.
with this?
No.
Are you familiar with slope intercept form?
Yeah.
Okay, so we'll do that.
So e equals.
And maybe that's what you were
3e.
doing and I misunderstood. Sorry.
I'm not sure.
So E equals
3e x plus
well,
b.
we know x is 1.
Oh yeah, yeah, 3e plus b.
Good. Is that fair?
Yeah.
Okay, so now it intersects, cuts the x-axis at point A, right?
Yeah.
So that's the x-intercept.
So y is 0.
Yeah, so A is x-intercept. Let y equals 0. So then 0 equals 3ex minus 2e. Is that right?
Yeah.
So if we solve for x, 2e equals 3ex.
Yeah.
Divide.
So
Go ahead.
2e over 3e equals x. So just 2/3 equals x.
Excellent. Yep. Now they asked for the coordinates, so we have to say that A has coordinates 2/3 0.
0.
Yep. When they say coordinates, it's x and y. Do you
Yeah.
ever have your eyes water and they just keep burning? That's what's happening to me.
Oh, yeah.
Okay. So B is y-intercept. So we're going to let x equal 0. Is that all right?
Yeah.
So y equals 3e times, and this is wonderful. So y equals -2e, and we already know that because b is the y-intercept, isn't it?
Yeah.
So we don't have to do that.
Mhm.
So b is at 0, -2e.
Okay.
Okay.
Yeah, makes sense.
All right. So let me get you an equation of normal. Example. I might be able to just tell you, and you might be able to, we might not have to do this. That's totally up to you. So do you know what a normal line is?
Something to do with the opposite reciprocal, I think,
Yeah.
but I couldn't define it.
A normal line is perpendicular to the tangent line. This is the important part, at the point of tangency.
Okay.
Perpendicular lines have gradients that are opposite reciprocals. Meaning you take the reciprocal and change the sign. You negate it.
Okay.
Okay. You want to do this one?
So I would just find the tangent line and change the gradient. Is it just that?
Well, you wouldn't have to find the tangent line. No, you don't do that. You don't just change the
No.
gradient. You
No,
use,
can we go through it then?
yeah. Yeah. Okay. You do need to take the derivative to find the slope, right? We already have a
Yeah.
point, which is wonderful.
Yeah.
But now we have to find the slope of the tangent line through that point.
Okay.
Okay. So I have f of x equals the square root of x squared plus 3. So I have a function within a function here. I have the square root and I have x squared plus 3. So what rule am I going to have to use?
I can't remember.
The chain rule.
General. Okay.
Chain rule is function within a function. Do you remember what the basic rule is for the chain rule?
Yeah, it's the derivative of the outside and then the derivative of the inside. So
Good. As long as you mean multiplied by the derivative of the inside.
So I would first make that root into a power, I guess.
Yay.
So I would have 1/2 x squared plus 3 multiplied by
What's going to happen with the
2x.
exponent?
Oh, right. Negative 1/2.
Good.
And then multiply that by 2x. And that's it.
Good. Now I have to plug in 1 here because that will give me the
Yeah.
slope of the tangent line, right?
Yeah.
Are you able to plug in 1 with a negative exponent and figure it out? Yeah, neither am I.
No.
So we're going to rewrite this. How are we going to rewrite it?
the bottom bracket is x squared plus 3 to the positive 1/2,
Okay,
and then the top bracket is just 1/2, I think. I mean, top, what do you say? The numerator
numerator.
is 2x times 1/2, so just x.
Good. You can also think of 1/2, like, I like to think, if I have a fraction, numerator stays on top, denominator stays on the bottom.
Okay.
And
Oh,
then you can
right.
just do that.
Okay.
So f prime of 1 would equal what?
Um,
Do you want to
1
put this as a radical,
over,
or are you okay with just 1/2?
that's okay. I think it's just a half. No,
Okay,
just 1
so,
over
yeah,
1 squared plus 3 divided by 2.
yeah.
Is that
Square
right?
root of 4 is 2, right?
Yeah.
So that's 1/2. So the slope of the tangent line, I'm going to go up here. So the gradient of the tangent line is equal to 1/2, right?
Yeah.
Hence, because I don't want to say so again, the slope of the normal is what?
Negative 2 over 1, so negative 2.
Good. Okay.
Okay.
And so we have a point, right?
Yeah.
So off we go,
So,
right? Point, -1, 2. So go ahead.
so 2 equals and negative 2 times -1, so 2 plus b. Yeah.
Okay.
And then e equals 4. No, 2. No, 0.
Are you tired, Lot?
A little bit.
You seem a little bit tired. I was going to ask if you were okay, but then I didn't want to do
Yeah,
that.
no, I'm good.
And then I was going to say you seem tired, but this is only our second session. So,
Yeah, no, I'm good. So
so then
then we
y
know
equals what?
negative 2x plus nothing.
Good. There you go.
Perfect.
I'd like to show you what that looks like. Okay, like on a graph.
Okay.
What the heck we're talking about? Or can you picture it, do you think?
I think I can, yeah. It's like a right angle with the button with the tangent, right?
Yep. Oh, it's not square anyway. Okay. All right. So how are we doing on time? Oh, good. We have time. So what would you like to do next?
I think there was topic on, it was called E and inverse, that I've never understood E and inverse in general, so I think that might be good for calculus. That was. I can find an example if you like.
Yeah, I'm looking at what your mom sent me.
Mhm.
E and ln.
Yeah.
Okay, I'll tell you, but then I do want to find examples.
Okay.
Okay, basically, do you have any idea about about E?
Not really. No.
Okay, well, it's a constant like pi,
Hmm.
and it's approximately equal to 2.78 blah 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 blah.
Okay.
Okay, and E, I'm going to send you a link to a video.
Hmm.
You don't necessarily have to watch it, but I will just tell you that E came about because in calculating interest on a bank account or an investment that is compounded continuously, which means the interest is calculated nonstop, the
Okay.
base of the exponential part of that calculation always goes to E.
Yeah.
Because if you're compounding continuously, you're compounding infinitely. And as that happens, the base is E,
Okay.
the base of the exponent, right? So with logarithms, if I just write, I don't know, log of X, and how familiar are you with logarithms?
We've done them a lot, but I'm really bad at them.
Okay. So if I ask you what's the base of this logarithm, would you be able to tell me?
X? Or
No,
E? Is it E?
if I wrote log, if I put a 5 here, the base is 5,
5. Okay.
right? But if I just write log X, this is called a common log, and I don't write the base because the base is 10.
Okay.
So if no base is written, the base is 10. Sorry about I have good handwriting days and bad handwriting days.
That's good.
This is called the common log. Now I'm going to slow
Okay.
down a bit. It's a little better. So that's the common log. Okay. And that's because we work in base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Okay.
That's why we have that. And we use it so often. And mathematicians are lazy / efficient that we don't want to write 10 all the time.
Okay.
Okay. So
Yeah.
then we have ln. That is the natural log. That's what ln stands for. Is ln, right?
Yeah.
And we made up ln because of the number E.
Okay.
Okay. So I'll just say, yeah, that's ln. The natural log ln has a base of E. So it's similar to the common log, and we use it so often that it gets its own special symbol or label, you would call it. So lnx, there's actually an E, base of E, always.
Okay.
So it's a shortcut, right? It's actually a logarithm. It's just log base E of X.
Okay.
Make sense?
Yeah.
Okay. So that's E and ln, but there's more to it, and I'm not quite sure what that is.
Yeah.
So are you my student who doesn't have a textbook?
Yeah.
Okay. So,
I
but
mean,
you have problems that have to do with it?
I think we were given a textbook, but
Okay.
we never used it, not once. I can find though, because the whole topic thing that my mom sent you, there's assignments in each of them.
Sure.
I will find it.
I feel bad for you. You're on this little break and you have to do this mathematics.
Yeah, it's okay.
Yes.
Should I share my screen?
Yeah, let me stop sharing. There you go.
Where is it? Ah, here it is. Okay,
Boom.
so we've got all these. And then the homework was always at the bottom. This is what the homework was.
Okay, well, let's go through that. Is that it?
Yeah.
For the homework?
We also had other stuff, but it's not related to the topic.
Yeah, no, it's not. Okay.
Okay, so I stop sharing my screen.
Yeah, I can do it too. So.
Okay.
What time is it?
It's pretty late. It's actually not. It's 6:30.
Oh, okay. Do anything fun today?
No, I just studied today. I did some history stuff, and so later on I'm meeting with my friends. So.
Oh, good. Good.
Yeah.
Okay, so I'm going to put these on a different page. Where are you trying to go to university in
Yes,
Europe?
I am. I've applied in the UK, in Madrid and Amsterdam.
So your IB score is really, really important.
My IB score is important, yeah, but I'm in a good place. So
You're in a good, you feel good?
yeah.
Okay.
I'm just receiving offers and rejections in the next few weeks, so we'll see.
My daughter is up at the university where she's going to, because she was invited to interview for a scholarship, and I couldn't go, but my wife, I really wanted to go, but I couldn't. So she's up there now. In fact, she's interviewing now. I'm really excited for her.
That's so, does she do IB?
She did certificate.
Oh, cool.
She didn't do the
That's
diploma program. Which I supported her. Her makeup is just that she would have lost her mind, so we don't want that.
My sister is the same.
Oh, really? Isn't that interesting? Because my son before her did it. Like he did the diploma program.
Yeah.
And she was like,
some people just.
Yeah. And she felt bad. She said, but Christopher did it. You're going to be disappointed. I'm like, honey, we're not. No. Your brother's an idiot. Forget it.
Yeah, no, definitely. It's the same with my family. It doesn't matter. But I do think so, because I give tutoring to some people, and you can just see some students just aren't. They just don't have the right mind space for it, I guess.
Right. It's too much, because it's a lot. Oh my gosh, it's so. The good thing is you'll be so well prepared for university. So well prepared.
Yeah.
That's
exactly.
the good thing. Okay, so this is a chain rule.
Yes.
Okay. So the first thing we need to know is if f of x, and we already did this, equals e to the x, f prime of x is also equal to e to the x. So that's just fantastic.
Yeah.
Okay. Now, if f of x equals the natural log of x, the derivative is equal to 1 over the absolute value of x. And usually the absolute value doesn't come into play, especially in IBSL. And it's only there because without going into much detail, the logarithm of a negative number does not exist.
Okay.
So that's why that's there. Okay.
Yeah.
All right. So find the first derivative using proper notation. Okay, so I don't know, does your teacher want you, instead of y prime, do they want dy dx? as proper notation?
I'm not sure. I don't think so. We usually use y prime.
Well, good. Okay, y prime. Now with e, the outside function is e to the x.
Yeah.
Here. So the derivative is e to whatever is up there.
Yeah.
We just leave it alone, multiplied by the derivative of the exponent. So times 2. So it's just 2e to the 2x plus 1.
Okay.
All right.
Yes.
Okay.
That makes sense.
Good. So here, derivative of natural log is 1 over the absolute value times the derivative, which is 2.
Yeah.
Outside times inside, which is 2 over natural log of the absolute value of 2x minus 5.
Okay. Yeah.
This pattern will always be the case. So for the chain rule with natural log. In other words, once you've got it, you don't have to write 1 over this times blah. You can immediately put the derivative on top and 1 over whatever this is.
Okay.
Oops. No longer need natural log there. Sorry.
Okay. Yeah.
Okay.
Makes sense. Yeah.
All right, here you go. Here comes your moment to shine.
Okay. Do I need to do the chain rule twice?
Well, the first rule we have to do is the product rule, because I have
Okay.
2 different functions, right?
Right. Okay. Yeah. So 2x times e to the 3x plus x squared times hold on, let me think. 3e to e to the 3x.
Look at you.
Okay.
Done. But you seem like a very, very polite person. So we're going to be mathematically polite and move that 3 up front.
Okay.
Now, you should not get any points off if you don't, but we don't want anybody thinking of you as mathematically rude now, do we?
No.
Okay. Let's try this one and then we'll call it a session.
Okay. I think I would move the x up first. So
I agree.
ex to times x to the negative 1/2
Excellent.
equals, oh, and then that's product rule. So then ex times x to the negative 1/2, and then again ex. So add again ex times negative 1/2 x to the power of negative 3/2.
Woohoo!
Cool.
And if you had to, you could rewrite all of this junk.
Yeah.
Now, okay, I'm gonna do the polite thing again. Negative exponents are just fine, but we're not gonna have plus and negative, are we, Lot?
No.
We're gonna fix that. We're gonna put the 1/2 in front. Because you're a civilized human being.
Yeah.
You don't have to, but you should.
Okay.
All right. Are you sniffling? Are you sick?
No, I'm not actually. I'm not sick.
Okay.
thankfully.
You're
Yeah.
just you're just a little tired.
Yeah.
All right. So we don't have another session scheduled, is that right?
Yeah, but I think my mom probably will.
Okay.
Yeah.
All right. Well, have fun with your friends.
Thank you.
All right.
You
See
have
you
a
soon.
good evening. Bye.
Bye.